So we're going to look at a miscellaneous question from 2013. So in here we're given a table, and then it says hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time this is given by a differentiable function. So this function is differentiable, where t is measured in minutes. So A says use the table in the data in the table to approximate c prime of 3.5. So we're given a table, we're asked to find this value, and so we're going to find the slope between 4 to 3 to get 3.5. So for A, c prime of 3.5 is basically the slope. At 4 is 12.8, and at 3 is 11.2 over 4 minus 3, and then we end up with 16. But now that we're taking a rate, don't forget the units. It's ounces per minute. So this ounces per minute. So that's the answer for A. B says, is there a time? So whenever they say is there a time, they're asking for a specific time, means they're asking for IVT or MVT. From 2 to 4, we see prime of t is 2. Justify your answer. So we know whenever they're asking us for a rate, or they're giving us a rate, they are asking for MVT. So c prime of t, how are we going to know if there's a time? So we take the average rate of change from 4 to 2 to see if there's a time where c prime of t is 2. So we take c of 4 minus c of 2 over 4 minus 4 minus 2. So this is, look at the table, we get the value. So that's 12.8 minus 8.8 over 2, which equals to 2. So we see that there is a time between 2 to 4 where t prime of t is 2. So we're gonna say c is differentiable and thus continuous, therefore by MVT there exists at least one time from 2 to 4 for which c prime of t equals to 2. So this is our entire answer to B. So we saw the rate and we realized that we have to do MVT. That means we have to get the average rate of change. So we got the average rate of change, and it was 2 as they asked. So we're going to justify saying that C is differentiable and thus continuous. Therefore, by MVT, there exists at least one time between 2 to 4 for which C prime of t is 2. So now C says use a midpoint sum with 3 subintervals of equal length to approximate 1 over 6 times the integral of 0 to 2 of c of t dt. Explain the meaning in the context of the problem. So first we're gonna do a midpoint Riemann sum. Oh, don't forget 1 over 6. 1 over 6 and 0 to 6 c t dt. Midpoint Riemann sum is when we take the midpoint between these two numbers. So 3 subintervals, and yeah, so 2 minus 0 is 2 times 5.3. 2 times 5.3 plus 2 times 11.3 plus 2 times 13.8 ounces. So when you calculate all of them, you don't even have to calculate this, because this is a no calculator problem and you don't have enough time to sit down and calculate all this. You can just leave it at this, and then we can, if you're leaving it at this, don't forget the unit and then explain the meaning. The meaning is 1/6 from 0 to 6 ct dt is the average, is the average amount of coffee in the cup from 2 to 6 minutes in ounces. So we said, so two things they're looking for is this is the average amount. So they're looking for the midpoint sum, and then they're also looking for you to say that this is the average amount. The reason why you are saying it's an average because of the 1/6. 1/6 is, we know the average velocity formula, 1/b minus a. So 1/6 is 1/6 minus 0, which is 1/6, is the average. So this is the average amount, and that's all you have to say when you explain this. So D says the amount of coffee in the cup in ounces is modeled by this equation. Use this model and find the rate. So immediately we know we have to get the derivative of this thing, which the amount of coffee in the cup is changing when T is 5. So BT is 16 minus, okay, so D, so BT is, what is it, 16 minus 16, okay. 16 minus 16 e times 0.4 t. Right? Yes. So we first have to do b prime of t and find t and find the value when t is 5. Okay. B prime of t 16. The derivative of 16 is 0. So this is 0 minus 16 times negative 0.4. We're doing the chain rule. No, we're not. We're not doing the chain rule, are we? And then E times 4. Oh, I wrote it wrong. So here's the derivative of this, and now we're gonna plug in when t is 5. 16 times negative 0.4 e times negative 0.4 times 5, and we're gonna leave it at ounces per minute, and we're not gonna solve it. We don't have to solve it because it's a no calculator problem, and I personally don't wanna solve this equation when we can just leave it at this. And this is the answer to D, because we found the derivative and then we plugged in 5. Thank you.